Today's math lesson was estimating sums, so I just wanted to go over that. The curriculum expectation is, this is what it says in our Ontario curriculum: use estimation when solving problems involving the addition, subtraction, and multiplication of whole numbers to help judge the reasonableness of a solution. So today we're strictly focused on the addition, and I think this is a very, very important skill for students to be able to do. And I'm going to be hammering home the idea that whenever they do any kind of calculations, whether it's with a calculator or doing calculations with pencil and paper, they should always have an idea in their head of what they think the answer should be. And we're going to show them how to use estimation to help them come up with a reasonable answer in their head, so that way when they do their calculations, if they make a mistake, even if they were doing something on the calculator, they enter a wrong number on the calculator, they might be able to catch it because they'll see that the answer wasn't at all what they were expecting. And then they might have to go back and do it again and catch a mistake. And that's the idea here. So we want students to understand that estimating means using friendlier numbers that you can calculate quickly in your head. Okay. The second big idea is that there are different strategies for estimating, and understanding how changing the numbers will affect the sum can help determine the best strategy. I'll show you what I mean when we get down to here. So a basic strategy is just to use the rounding strategy. And we're working with 3-digit or 4-digit numbers. And so if I wanted to round this to the nearest 100, I would get 300 plus 300 equals 600. In example 2, I could just round to the nearest 1,000, and here be 4,000 plus 5,000 equals 9,000. And students would be allowed to round to the nearest 1,000, or if they could also round to the nearest 100. In this case it would be 4,200 plus 5,400. And if they could do some mental math here, a little bit trickier mental math, so we would have 9,600. Really a big thing is for them to recognize that by rounding to the nearest 100, you're going to get a more accurate estimate. So it's not that this is wrong, but it's not as accurate as this should be. And then finally, there's a great question in the test book that got assigned today. It's not exactly this, but similar. It's the idea that if I choose a strategy of rounding this to the nearest 100, I'm going to get 500 plus 500 equals 1,000. Okay? What's wrong with that? So I want students to be able to get an understanding of what are we doing to the number. Well, this number we've added by 49. We've added by almost 50, and this number we've added by almost 50. So this estimate here is going to be very, very high. So is there a better strategy to use in this case? If we did something like 400 plus 500, we know that we're rounding this number down by about 50, and we're rounding this number up by about 50. We're going to get 900. So another thing to do in this case is to just turn 451 into 450, and the same for the other one. You get 450 plus 450 is 900. So we want students to be able to recognize, if I just rounded this number up, and if I just rounded this number up, and now I'm adding them together, I'm going to be a little bit off. Maybe I can get a better estimate by doing something a little bit differently. This example up here is a very good example. Same idea. If I'm using the strategy of rounding to the nearest 1,000, I'm rounding down by a little bit more than 200, and I'm rounding down here by almost 400. So I'm going to be about 600 off of the correct answer, which is a little bit, not a very accurate estimate. So one strategy to do here differently would be to round to the nearest 100 and get a more accurate estimate. Another possibility is to go round 4,200 down to 4,000 and round 5,378 up to 5,500. And that'll get you to 9,500. So to summarize, we start with a basic idea that a main idea of estimating is just round the numbers to a friendlier number. Then, to get a deeper understanding, we're going to have students look at these numbers and look at how we're changing them to see, and then asking the question, is that going to get you a very good estimate? Could you do something different to get a more accurate estimate? And that is the tricky part, which is a little bit difficult. We're going to practice this more in the next few days.